Hello everyone, and welcome back to our series. Today we're diving into episode 16, and we're tackling a technology that has completely reshaped the software world, Docker. You've probably heard the name thrown around a lot. You might have seen the cute whale logo or heard developers singing its praises. But what is it really? Is it just a fancy way to package cargo, your application, or is it something more fundamental? I've heard some people say it's like packaging the entire dock. That's the question we're going to unpack today. So let's start with the problem Docker solves. Imagine you're a developer. You build this amazing application on your laptop. It works perfectly. You've got your specific version of Python, your specific libraries, and all the configurations are just right. You're happy. Then you hand it over to your colleague or you try to deploy it to a server. Suddenly, chaos. It breaks. It works on my machine, becomes the famous last words. Why? Because their machine is different. It has a different operating system version, a different library version, or some hidden setting is missing. The application has all these implicit prerequisites that you didn't even realize were there. It's like trying to assemble furniture from a certain store, but you need a specific, non-standard screwdriver that wasn't included in the box. It's incredibly frustrating and a huge waste of time for everyone involved. This is the exact headache that Docker was designed to cure. The core insight behind Docker is brilliantly simple. Instead of just packaging your code, what if you could package your code plus its entire runtime environment? This includes all the dependencies, all the libraries, the configuration files, everything your application needs to run, all bundled together into a neat little package. This package is called a container. Think of it as a standardized, isolated, and self-sufficient bubble where your application can live happily, no matter where you put it. By doing this, we eliminate those pesky implicit prerequisites. The container holds everything needed for execution, making the underlying host machine almost irrelevant. As long as the host can run Docker, it can run your container, and your application will behave exactly the same way every single time. It's a game changer for consistency and reliability. To really get our heads around this, let's use what I call the great logistics metaphor. This analogy is so perfect, it's almost as if Docker's creators were inspired by the global shipping industry. Imagine your application is some precious cargo, let's say a bunch of bananas. In the old days, before standardized shipping, you'd have to load the bananas onto a truck by hand, then unload them at the port, then load them onto a ship, and repeat the process at every step. It was slow, inefficient, and you probably bruise a lot of bananas. Now, think about modern shipping. What do we use? Intermodal containers. Those big rectangular steel boxes you see on ships, trains, and trucks. You pack your bananas into one of these standard boxes at the farm. Once it's sealed, nobody cares what's inside. The box can be moved from a truck to a train to a giant cargo ship using the same standardized equipment, cranes, forklifts, etc. The box is the unit of transport, not the bananas. In our analogy, a Docker container is that intermodal box. It's a standard unit that holds your application and its environment. It doesn't matter what's inside a Python app, a Java service. A database, the way you handle the container, is always the same. So what about a Docker image? Well, the image is like the blueprint or the template for the box. It's the set of instructions for how to build your container. For our bananas, the image would be a specification that says, start with a refrigerated box. Install shelves at these specific heights, and set the temperature to 13 degrees Celsius. Use this image to create as many identical containers or boxes of bananas as you need. In the software world, the image might say, start with an Ubuntu operating system, install Python 3.9, copy my application code into this directory, and run this specific command to start it. This image is a lightweight, read-only template. When you run the image, you create a runnable instance of it, which is the container. This separation of image and container is powerful. You can build an image once and then deploy it to create hundreds of identical containers across different environments. This brings us to the final, magical piece of the puzzle, portability. The slogan for intermodal containers is runs anywhere. A box packed in a factory in China can be unpacked in a warehouse in Ohio without ever being opened in between. It travels seamlessly across different modes of transport because the infrastructure, the ports, the ships, the trains, is designed to handle the standard box. Docker provides the same promise. A container built on a developer Mac laptop will run identically on a Linux server in a cloud data center or on a Windows machine in a testing environment. As long as the host system has the Docker engine installed, our equivalent of the port's cranes, it can run the container. The host operating system simply provides the kernel and the resources, while the container brings everything else it needs. This incredible portability is why we say Docker doesn't just package the cargo. It packages the dock itself, or at least a standardized interface to the dock. It creates a universal execution environment that can be moved and run anywhere, dramatically simplifying development, testing, and deployment. It's the build once, run anywhere dream, finally made real. So, we've seen how Docker uses containers to package an application along with its dependencies, creating a portable and consistent execution environment. It's like putting our app in a magic box that works everywhere. This is fantastic when you're dealing with a single application or a single service. But what happens when you have a modern, complex application? Most apps today aren't just one single monolith. They are composed of multiple interconnected services: a web front end, a backend API, a database, a caching layer, maybe a messaging queue. This is where the concept of microservices comes in, and it's where Docker truly shines. Imagine trying to manage all those moving parts. Each service might be its own container. How do you make them talk to each other? How do you start them all up in the right order? How do you scale just one part of the system, say? You need more web servers, but only one database. Doing this manually would be a nightmare. You'd be back to juggling configurations and dependencies, just at a higher level. This is where our next topic comes in: container orchestration. We need a conductor for our orchestra of containers. We need a system that can manage the lifecycle of multiple containers, handle networking between them, manage their data, and scale them up or down automatically. This is the next level of the container revolution. In our next video, we'll start exploring the powerful tools designed for exactly this purpose, like Docker Compose and Kubernetes. We'll see how you can define your entire multi-service application in a single file and bring it to life with a single command. It's where we move from managing individual boxes to managing an entire fleet of them. I hope this has given you a solid understanding of what Docker is and the fundamental problem it solves. It's all about creating predictable, portable, and isolated environments for our software. If you found this explanation helpful, please give this video a thumbs up and hit that subscribe button so you don't miss our deep dive into container orchestration. Thanks for watching, and I'll see you in the next one.